So in this assignment here, the balancing equations by drawing them, it'll give you a way to visualize why balancing equations are important. So we're going to be using shapes, and you're going to be drawing in shapes based on what it says here. So here we have Na, and down here it tells you what color to use. So the sodium circle, they want you to do as red, and then you draw in however many you have. So I have one red sodium circle there, okay, Na, 1 Na. And then I have an O here, and so that's going to be green. And so you kind of draw that in next to it. And then you have an H, and that's orange. Let me get a better orange. Okay, so NaOH. Okay, then next you have HCl. So you have H, which is hydrogen, and again that's orange. And then you have Cl, which is chlorine, and that one's going to be yellow. I need a yellow. And so draw a yellow next to that. Alright, so NaOH plus HCl gives me NaCl. So Na again was red. So draw a red circle next to Cl, which was a yellow. So there is NaCl. And then H2O. So H is orange. And there are two of them. And then O is green, and there's just one of them. Okay, so then the next thing you do is you look to see if you need to add coefficients. This is the whole reason we balance equations. So this is a way to help you visualize that. So here we have one red circle. Over here on this side of the arrow we have one red circle. Here we have one green circle on this side of the arrow, and on this side of the arrow we have one green circle. And then over here we have two orange circles, and over here we have two orange circles. And then on the left side you have one yellow circle, and on the right side you have one yellow circle. So everything is balanced, and so these blanks in front here where we would put coefficients if it wasn't balanced, we're just going to leave those blank. You don't have to put in any numbers, you do not have to put in ones. So here we go on to the next one. So you have K, which is potassium, and that's red, and so a red circle. And then iodine is green, so next to a green circle. And then Pb, which is lead, and that's yellow. And then NO3, I talked about this in the notes, this is a polyatomic ion. So NO3, and remember parentheses give it away that it's polyatomic, also capital letters. I have 1, 2, 3 capital letters in this compound, so that kind of clues me in that I have a polyatomic here, whereas over here in this compound I only have 1, 2 capital letters. So anytime you have more than 2, you probably have a polyatomic in your compound here. So 1, 2, 3 capital letters. So NO3 is the polyatomic, and that's called nitrate, and so we're going to treat that as if it's one thing, and that's going to be purple. So NO3, but there are two of them. So when I go to draw my circles, I'm going to draw two purple circles here. Okay, so there's two purple circles with that one lead. This 2 only goes to the NO3, it doesn't belong to the Pb in front. Then over here we have K, so again I need red. And then NO3, so again that's a polyatomic, and I'm going to treat that as if it's one thing, and so there's one NO3, and so there's going to be one purple circle. That 3 there does not mean that there are 3 NO3s. That 3 belongs to the O, and that's all part of one thing. So you treat polyatomics as if they're one object, even though they've got multiple things inside. And that's something you'll just get used to with practice. So I've given you some hints on how to see them, but even if you missed it, even if you didn't notice the polyatomic, if you balance the K and the N and the O separate, you'd still get the right answer. It's just a little bit more work. And then I have Pb, which is lead, so that's going to be yellow. and then that's bonded to I2, and I is iodine, and that's going to be green. And green circles here. Alright, so now I count my circles. I have one red circle on the left, one red circle on the right. I have one green circle on the left and two green circles on the right, so that doesn't balance. So then what I need to do is I need two green circles over here. So I'm going to draw an extra green circle. But green circles don't just come in by themselves as green circles. That's not how you balance equations. Matter doesn't just pop in. It has to come in the original form that it came with. And so it originally came in with a red and a green together. So if I add in anything, I have to add in those two things together. So you have to add in sets of what you already have. You can't just add in single pieces. So now I have two green circles over here and two green circles over here. So right here, I have one yellow circle, and then I have one yellow circle over here. And then I have two purple circles right here and one purple circle over here, so that doesn't match either. So I need to add in another purple circle, but like I said before, you don't just add in single circles, you have to add them with the partner that they came in with the first time. So add them in sets of red, purple. So now, at one point in time when I added this green, that upset my balance of reds, but adding this other compound balanced that back out. So now everything is the same, both the left and the right. And so what you have to do is you have to add your coefficients. So you can type those, but I'm going to do them with a pen here. So I have how many Ki's? Well, there's one here, and then there's two there. So this is how many molecules do you have of Ki, and so you need to add the coefficient 2 in front. I still have one PbNO3. Now I have two KNO3s, so this needs a coefficient here of 2, and then this one has the original 1 PbI2. And when it's 1, you don't put a 1 there. It wouldn't be wrong if you did, it's just that's not something that chemists tend to do. So I'm going to take that away. Alright, so I'll do one more with you and then I'll leave the rest of the document for you. So H2O2 gives you H2O. So go back to my circle tool, and then I have H2, hydrogen is orange. So two orange circles together. And then oxygen is going to be green. So two green circles together, because it's O2. And then H2O, there are two hydrogens, so two orange circles together. And then there is one oxygen, which is a green circle. So I'll kind of put that in between. Alright, so now I count. I've got two oranges over here, two oranges over here, I have two greens over here, but I only have one green over here. So I need to add another green. But remember, like we said before, you can't just add green. You have to add it with the original molecule that it came with. And so it came with these other oranges attached to it as well. And so it came as a water molecule. So now I go through and I look, orange, I've got two oranges over here, and now I have four oranges over here. So I need to add two more oranges, but they need to be in compound form because that's their original form in this equation. Okay, so they're bonded together. So four oranges over here, four oranges over here, two oranges over here, or two greens in the middle here, and then two greens on the right side. So then this equation is now balanced. You grab your pen tool and you count. So I have 1, 2 of these hydrogen molecules. So there's a 2 that goes here. I only have one oxygen molecule, so you can put the 1 if you really want to, but chemists tend to just leave those blank. And then over here I have 2 sets of water. So this would be 1 and this would be the other one. And so there's going to be a 2 that goes right here. So that is how you balance equations. You're going to keep doing that for the rest of this document. You're drawing them out to visualize why we do that. Why do we add these numbers here, these called coefficients, and this document will help you see that.